I am Lou Zanoni, President of Zantech Corporation, and it is my pleasure to introduce to you the latest and most advanced quartz watch analyzer on the market today. The ZA900 quartz watch analyzer provides you with the capabilities of determining the nature of a problem in a quartz watch in just a few minutes. It simplifies estimates and speeds up service for greater profits. Greg Zanoni, a quartz watch engineer and principal designer of the ZA900, will demonstrate its many features and functions and how they are used to analyze the problems of a quartz watch, quickly and accurately.
Let us begin by turning the instrument on. The main power switch is in the lower right-hand corner. There are 3 watch battery power sources available at the battery jacks. The most common is the 1.5 volt power supply. It is present at the battery terminals when the battery voltage button reads 1.5 V. This is the most common voltage supply used to test quartz analog and digital watches. At the push of this button, the 1.5 volts at the battery jacks becomes 3.1 volts. The 3.1 volt power supply is used as a substitute for lithium batteries and for the older LED watches that use 2 silver oxide batteries in series. At the touch of the variable voltage button, the 1.5 volt power supply at the battery jacks becomes a variable voltage power supply that is adjustable from 0 to 2 volts. To adjust the voltage, simply slide the variable voltage slide pot to the appropriate voltage as indicated on the bottom scale of the meter. The variable voltage feature has many uses. It can substitute for the 1.3 volt mercury battery in an Accutron watch or any other non-quartz electric watch. It can be used to phase an Accutron by adjusting the voltage, but its most important function is the low voltage test or movement cleanliness test on a quartz analog watch. The current consumption of a movement is one of the most revealing tests that can be performed on a quartz watch. To measure current, push in the current drain button. There are 2 current ranges on the ZA900. The low current scale measures from 0 to 10 microamps. This covers the normal operating current drain of any quartz analog or quartz digital watch. The high current scale measures from 0 to 100 milliamps. The model ZA900 automatically changes to this scale when the current drain from the movement is greater than 10 microamps. The pilot lights under the meter indicate which current scale to read. One very important feature of the current measuring capabilities of the ZA900 is the clicking sound it makes when it changes scales from 10 microamps to 100 milliamps. Each time a quartz analog circuit board sends a pulse into its motor coil, it draws a high current from the battery terminals of the watch. When it does, you can clearly hear the click of the scales changing. This indicates that the circuit board is functioning and that it is sending high current pulses into the coil. This indicates a good coil. This clicking sound occurs immediately after the 1.5 volt battery voltage supply is connected to the battery terminals of the movement. This clicking sound is very helpful when doing estimates. You can tell within seconds whether or not the circuit board and coil are good merely by connecting the battery terminals of the watch to the battery output terminals of the ZA900. Current readings: high, low, fluctuating, or none at all provide important information for servicing quartz watches. The ability of being able to interpret the current drain readings and the clicks of the quartz watch analyzer is extremely useful when trying to track down watch problems. Audible coil test. The audible coil test is a new unique feature of the ZA900. The instrument buzzes when testing a good coil, and there is no need to disconnect the coil from the circuit board. When there is uncertainty about the continuity of a watch coil, simply push in the coil test button, plug the dual tip probe into the coil test motor drive terminals, and probe the 2 coil contact pads on the circuit board. If the coil is good, the instrument will buzz. It will not buzz if the coil is broken or if the coil terminals are shorted together. It only buzzes when the coil resistance is between 500 and 10,000 ohms. Motor drive. When the motor drive button is pushed in, the coil test motor drive output jacks change from a coil test output to an alternating pulse for driving a watch motor coil. The output pulses from the motor drive jacks are similar to the output pulses of a watch circuit board. The dual-tip probe from these jacks acts as a substitute for the complete watch circuit board. The 1-second pulsing from the motor drive speeds up testing of movements which normally pulse once every 10, 20, or even 60 seconds. To use the motor drive, press in the motor drive button and connect the dual-tip probe or 2 cable probes into the coil test motor drive output jacks. Remove the watch circuit board from the movement. Probe the coil contact pads with the points of the cable probes. If the coil, stator, rotor, and gear train are okay, the wheels will begin to turn. If the wheels do not turn, there is probably a mechanical problem in the gear train of the motor assembly. If the wheels do turn, it can then be presumed that the problem is elsewhere, more likely in the circuit board and or its connections. Analog circuit board testing. The Zantech analyzers model 800 AV and now the new ZA900 are the only reliable instruments capable of testing a quartz analog circuit board after it has been separated from the movement. The procedure is simple. First, connect the green and red mini hooks into the color-coded battery voltage jacks. Then connect the mini hooks to the appropriate battery contact pads on the circuit board. Push in the current button. When a normal current reading is obtained, short-circuit the 2 coil contact pads on the circuit board with a pair of tweezers. The short across the coil contact pads represents a substitute for the coil. If the circuit board is good, the analyzer will begin to click each time the circuit board sends a pulse through the tweezer, just as if a good coil were connected to the circuit board. The pulses and clicks may occur once a second or every 20, 30, or even 60 seconds. Listen for the clicks. They are a sure sign of a good circuit board. Quartz crystal test. Quartz crystals can be tested while they are still on the circuit board. In most instances, it is not even necessary to disassemble the movement. The output jack marked quartz crystal substitute provides a 32,768 Hz signal similar to the one generated by the quartz crystal in a watch. Therefore, if a quartz crystal is faulty, the watch can be made to run by injecting the substitute quartz crystal signal into the watch at the solder terminals of the quartz crystal. It is only necessary to make contact to one of the quartz crystal solder terminals with the probe to determine if the quartz crystal is defective. To perform this test, power must first be applied to the movement battery terminals. This will provide the energy to run the watch when the substitute signal is injected into the quartz crystal terminal. If the substitute signal does not start the watch running, it can be assumed there is some other problem. If the movement begins to run, it can be assumed that the quartz crystal is faulty and must be replaced. Switch contact. All digitals, Digianas, and some analog watches require electronic push-button contacts for setting. These electronic setting functions are easily tested with a probe from the switch contact jack of the ZA900. Many quartz watch problems are related to casing of the movement or module. Therefore, it is very important to be able to test all of the functions of a module or movement outside of its case. To test a module, connect the battery voltage supply of the instrument to the battery contact springs of the module or movement. Plug a probe cable into the switch contact jack and use the sharp point of the switch probe to activate the electronic setting functions of the module or movement by probing the contacts on the side or top of the module. The probe is useful in breaking through dirt on the contacts and tracing broken contacts on the circuit board of the movement. When you are assured the movement is good, you can concentrate on casing it properly. Voltage measurements. There are two voltage measuring ranges, a 0 to 2 volt range and a 0 to 10 volt range. When either of these two buttons are pushed in, the meter becomes a very high impedance voltmeter. The voltmeter probe can then be used to measure voltages on any quartz watch without loading the circuit. When a module or movement is connected to the main power source through the battery terminals of the instrument, it is only necessary to use one shielded probe to measure voltages on the circuit board. The common connection of the voltmeter is connected through the positive battery terminal. This simplifies testing and the tracing of open circuits. The voltmeter input is also used in conjunction with the Zantech Model 810 battery tester. With the aid of the variable load of the battery tester, a wide variety of sizes and types of watch batteries can be tested accurately. To test a battery, slide it under the clip. Push in the 2-volt meter scale button and read the open circuit battery voltage on the 2-volt range of the meter. New silver oxide batteries measure 1.58 volts. The true test of a battery is how it performs under load. A light bulb drains a lot of current from the battery. It is equivalent to a 100 ohm load. To apply a load with the 810 battery tester, dial in the appropriate load and press the load button. The meter will indicate the quality of the battery. A new battery will maintain its voltage under load, while a weak battery will not. To obtain the proper test load for any battery, compare it to a new one. Overload protection. The overload protection circuit of the ZA900 has been designed to shut down the main power supply to the movement if the battery terminals are shorted or if a short circuit exists on the circuit board. The overload circuit will reset itself after a few seconds when the cables are disconnected. This overload circuit was designed to protect movements and to help solve problems. The basic troubleshooting procedure should be performed in the following sequence. Step number 1. Remove the battery and examine the battery cavity for broken contacts or contaminants. Step number 2. Supply power to the movement with the mini hooks from the ZA900. Connect the green mini hook to the negative battery contact and the red to the positive contact. Step number 3. Measure the current drain. Current must flow into the circuit board before anything else can happen. Step number 4. Determine if the oscillator is running by placing the movement next to the sensor of the Model 1100 timer. The timer will display the accuracy in seconds per month. Use your remote probe for greater convenience. Step number 5. Check the stem to be sure it is in the run position. Step number 6. Listen for the coil clicks. The clicks indicate that the circuit board and the coil are good. Be aware that some movements only click once every 5, 10, 20, and some every 60 seconds. Next, closely observe the gear train motion. Make sure the wheels are turning, not just bouncing. The final step is the low voltage test. This test determines the cleanliness of the gear train and the freedom of the wheels and hands. The lower the operating voltage, the better the movement. The low voltage test scale on the meter will indicate the condition of the gear train. Isolating the problem. 3 major indicators are used to isolate and identify the problems in quartz watches: current flow, oscillations from the quartz crystal, and the clicks caused by the current pulses into the coil. To isolate the problem, we must ask the following questions. Is current flowing? Is the oscillator running? Is the coil good? Is the gear train turning? How free is the gear train? If the answer to these questions are no current, no oscillator, and no coil clicks, check the battery hookup and the circuit board connections. When the current flow is normal and the oscillator is not vibrating and no coil clicks are heard, examine the oscillator components. Then probe the quartz crystal of the movement with the quartz probe while the movement is powered by the analyzer. If the current is normal and the oscillator is running, but there are no coil clicks, push in the stem to the run position. Then examine the coil circuit board contacts and, of course, test the coil for continuity. If you have current flow and the oscillator is running and the coil clicks are emanating from the ZA900, check the gear train to be certain it is moving. Check the hands to be sure they are free to move. Finally, perform the low voltage test. The low voltage test determines the condition of the watch. A standard silver oxide watch battery supplies 1.58 volts to the movement. If the watch stops running above 1.4 volts, it is very poor and must be cleaned and serviced. If the watch stops at 1.35 volts, it should be cleaned and checked for friction between the dial and hands. A watch that is capable of running at 1.2 volts or lower is considered clean and free running, and no further service is required. For additional details on troubleshooting and servicing quartz watches with the ZA900 quartz watch analyzer, consult the written instructions which are included with each instrument. If you have any other technical questions, please feel free to call us. Thank you for your attention. We are looking forward to serving you.
Zantech Corporation is a manufacturer who specializes in quartz watch test instruments and is a major supplier of a wide variety of quartz watch analog movements, brand name watch batteries, crystals and case parts for Armatron, Casio, Seiko, Pulsar, and Citizen, as well as all of the required tools to facilitate watch repair. Our 3-day quartz watch training class has benefited numerous watchmakers, jewelers, and entrepreneurs. For a class application and a catalog, or to place a material order, call our toll-free number 800-441-7569.